Hi, I'd like to now introduce the software application that I've been using in the videos you've seen thus far. The name of the application is Geogebra, and you can download the latest copy from this website. This application, which is totally free by the way, is designed primarily as an aid to the teaching and learning of mathematics and science, and I have found it to be especially useful when applied to certain topics in physics. I am registered with Geogebra, that's why you see my picture over here. However, in order to get materials or to download the application, you do not need to register with Geogebra. So to download this application, which is the first thing you're going to need to do, you just come over here, click downloads, and then if you're going to install Geogebra on a tablet, then you click from these. But most of you probably will work with Windows, so you come here and simply click here. You will be asked for the folder to save a small executable, and from that point on you simply follow the instructions. Okay, so once you have installed the application, you will get a shortcut on your desktop. Simply click or double click and Geogebra will start up. This is the default screen you will get when you start Geogebra. By perspectives, they are referring to the various views offered by the Geogebra interface. The two views, perspectives, that we will work with mostly are the algebra view and the graphics view, which are the default. The algebra view provides us with a list of the objects that we create. These objects can be points, lines, text boxes, vectors, angles, sliders, and more. The graphics view is where the objects are presented in some specific layout. As you begin to work with Geogebra, if you haven't chosen any of these perspectives, this little display will disappear. So I just click on the screen and it's gone. If you want to get one of those perspectives, you can simply come to view here and pick. As you work with Geogebra, your attention will be focused primarily on the graphics perspective. Here we have two axes, the Y and X axes. We can move this entire area about by simply left clicking, that's your normal click, and dragging. So I'm just dragging this around. If I want a grid, I can simply come here and show the grid or not. I can also choose to show the axes or not. As we have it here, these axes run from -4 to 4 and from -5 to 5. We can change this, for example, and have this run from, let's say, -40 to 40 and from -50 to 50. I simply come here, notice, bring the mouse right over the line, right click, then pick graphics, and then I get this properties dialog box, and there's a lot we can work with here. But for right now, we'll just look at some basic things. From -50 to 50 and from -40 to 40, and there we have it. For the purposes of what we'll do next, let's just get rid of these little numbers and the little tick marks. So we can do that again. Notice, just come over here, and now I come to the x-axis and I say show numbers and no ticks. Go to the y-axis, take off show numbers, and there we have this. Now let's create some objects. There are two principal ways of doing this. One is to use the toolbar. And so we simply come up here, for example, and if we want a point, we simply come here and we click and place points where we want. So like I said before, in the graphics view we see the spatial layout of our objects, and in the algebra view we simply get a list of the objects. You can toggle the visibility of these objects. You can right click, for example, and say show object, but perhaps it's simply easier to come over here and click it like this. Notice the object has disappeared. Now from this point on, we can't select that object over here in the graphics view anymore, but it's still over here, so I can come over here and make it visible again. Instead of using the toolbar, however, we can also use the input bar. And so I can make a point, let's say E equal, and let's put it right in the origin and just say 0, 0, and then I press enter, and there it is, right in the origin. Let's make some vectors now using the input bar. Geogebra expects that the names of points will begin with capital letters. Likewise, for vectors, the names should begin with small letters. To specify a vector, you can give the scalar components of the vector, or you can give its magnitude and direction, expressing that direction as an angle measured counterclockwise from the positive x direction. So let's make a vector A, and let's say that vector A is going to have components. Let's say the x component will be 30 units and the y component will be 17 units. Note that in Geogebra we don't have the ability to put a little arrow on top of the vector name, so you'll just have to get used to that. So this is 3017, and Very important is the fact that I've placed a comma here. By placing a comma, Geogebra understands this as the two scalar components, so I can press enter and there we have our vector. 30 across, 17 up. I can also place a vector in this quadrant. For example, I can say b equal, and I can say it's, let's say, minus 20, and then down, say 35. And I did not, let's do that again, minus 20 and down 35, so I forgot to put negative sign. There we go. If you don't like seeing these labels, we can just come here and take off the label. We can do it from in here also. Of course, we can change this to polar coordinates, and so now we have the magnitude and the direction measured counterclockwise from the positive x direction. So let's leave it the way we input the vectors. I can also specify a vector as a magnitude and a direction. So let's suppose the vector c is going to be a vector whose magnitude is, let's say, 40, and at a direction of, say, 65 degrees. Note I use a semicolon here. So when I put a semicolon here, Geogebra understands that this vector is being specified as a magnitude and a direction. Now to put the angle, I simply write, say, 60 degrees, but I have to put the little degree sign. Otherwise, Geogebra will understand the value to be in radians. So I can use this little thing here to put the degree sign, or I can hold down the key, the Alt key, and while I'm holding that, press small o, and there it is. There I have a vector whose magnitude is 40 and at an angle of 60 degrees from the x positive direction. Of course, I can also see this in Cartesian coordinates. That's 20 across, 34.64 up. I can specify the angle in radians like I said just now, so I can say d is let's say 50, and let's say the angle in radians is almost pi radians, so I'll just put 3 instead of 3.14. Remember, you need to have a semicolon, so let's say 3. And that should put the vector somewhere over here. So there we have it. Notice that Geogebra still shows you in degrees, even though you put that value in as in radians. You can express the angle using in terms of pi. So you might not be used to this, but I can say let's suppose I want to make it 270 degrees. That'll be down here. I can say it has a magnitude of 40 and then put semicolon. Now I want 270. That's 3 pi over 2. I can go 3 divided by 2 times pi. And I can get that pi by coming here and putting the pi symbol, or I can simply hold down the Alt key and press P, and there it is. I don't know if you remember this, but 3 pi over 2 is 270. If I wanted 90 degrees, then that would be just pi over 2. So I could say, the vector f is equal to, let's say, 30, magnitude of 30, and then pi over 2. So that's Alt P divided by 2, and there we go. There it is. So we'll end this now, and in the next video we'll look at some applications of what we've learned here. Bye for now.